Hello, everyone. Today, I've chosen the topic of detection and classification of AI-generated fake news. Our aim here is to spark a thought-provoking conversation about the potential of using simple machine learning techniques in the realm of detecting and classifying AI-generated fake news. By inducing this thought, we hope to inspire further exploration and advancement in the critical field of research. If we go to the next slide, please. Yeah, so considering the background and motivation of the study, as we all have seen that the reach of fake news that has in the recent state of pandemic, so almost everybody across the world have experienced that, I'm sure. Going to the next slide. So considering the online fake news or information which is deliberately designed to deceive readers is most commonly manually written, but the recent progress in natural language generation techniques, models have been built to generate realistic looking fake news. Considering that AI is capable of generating legitimate looking text that appears credible to human eye, it has become very critical to not just differentiate the fake news generated by humans. However, it's also to we should be able to flag the fake news which is generated by the machines. Okay, considering that, we started with a literature review in the same field. There are several exploratory analysis results that have been presented in identifying of linguistic differences. However, it is majorly on the human written text, not on the machine written. Then uh, the analysis based on the language, the stage of the language, like it's whether it's vague or unclear, and any sensationalized news has been generated. So to just by using the intense words, which can be used to classify fake versus real. Considering these various papers we went through and we did some analysis based on that. Uh, Moving ahead in the next slide, it's also we have also considered a few papers which have talked about using the large language models themselves to distinguish between the articles which are human written fake news as well as the machine written data. However, when it comes to the truthful and fake information, if both are machine generated, it is not able to distinguish between those texts. So, with all this background, we started and we came up with a problem statement. If we can go to the next slide. Can we go to the next slide, please? So we'll talk about the problem statement here. So we came up with a simple problem statement that how efficiently can machine-generated fake news be flagged with the use of different simple classification techniques, and can we have a simpler model which can perform well in detecting both human or machine-generated fake news. With this in mind, we had an objective to do a comparative analysis of human and machine-generated fake news text, and to build a simple classifier to pick out the machine-generated fake news effectively. Moving ahead, just quickly to talk about the methodology that we used for this study. We did a literature and background study first, and we identified the data sets, some pre-labeled data sets, smaller data sets, although for an experimental purpose. Then we did the exploratory analysis to compare the writing styles, then did the classifier, built some simple classifier models and did experiments with the model evaluation. And to end, we will discuss the conclusion and then the future scope for the study. Moving ahead to the next slide, we did we so the data selection part, we have considered the BuzzFeed data sets which contains human written fake news as well as the human written real news articles. To create for the machine written fake news, we have considered Grover model and generated fake news articles with for various domains like healthcare, political, criminal, and also some sports kind of news or entertainment. Then the data pre-processing, we did the basics, lower casing, then noise removal techniques, stop word removals, and parts of speech tagging. Then we did, for feature engineering, we did the vectorization, TF-IDF method for unigrams and bigrams. Moving ahead, we also so moving to the next slide, please. We also proposed here, considering that the data annotation is the biggest task when we want to build a classifier model, we also propose that the active learning technique for annotation should be used, wherein we can start with with the model starts with a small set of labeled data and then iteratively selects the most uncertain examples for annotation by a human expert. The expert annotates these samples and then the model is retrained on the updated labeled data. This process continues until the model achieves a desired level of accuracy. This will definitely help us reduce the cost of annotation and the labeled data that we need upfront for the model training. Considering this, we move ahead and discuss the analysis that we did. So can we go to the next slide where we have compared the texts that the data sets that we had. We had human generated fake news, machine generated fake news, and the real news data sets. We considered the overall length of the articles, where we can see a lot of variation in terms of human written text. However, machine written text doesn't show much variation in terms of the total length of the article. Moving ahead to the next slide. Yeah, here we also compare the number of sentences per article and the distinct word count. Here as well, if we see human writing styles are more showing more variations as compared to the machine generated news articles, and the limited word corpus is quite visible if we consider the distinct word count here in terms of the machine generated fake news. Going to the next slide, we did compare the parts of speech tags, and the most commonly used parts of speech tags in our articles were common noun, proper noun, and the prepositions. So when we compared, it was visible that the usage of common nouns is quite high in terms of when we consider machine generated fake news. However, humans use almost same number of common nouns in both real as well as fake news articles. Now, coming to the proper nouns, it is actually quite obvious that the real news has more number of proper nouns, which indicates that the facts and the actual information, the factual information is evident here in the real news, as the humans are using more proper nouns. And but however, if we compare only the fake news, the human generated and the machine generated fake news, it is evident that humans can do a better job in coming up with artificial names and artificial nouns. Considering all of this with this analysis and comparing it, we then came to the step to build the classifiers with all these features in mind. And so if you can go to the next slide, we have chosen very simple linear classification models for our experiments here, which are very popular models for text classification methods. So it's naive-based, logistic regression, and support vector machine. With these models, we have, as we all know, that linear models are quite simpler to implement, more generalizable, and still the results are expected to be at par with other complex classifiers like neural networks. Using the above classifiers, we performed various iterations with feature sets on unigrams and bigrams. The most or the best of the iterations are discussed further in the results section. We can go to the next slide. So Yeah, so where if considering the human written fake versus human written real news data sets, SVM did a decent job of giving us the accuracy of 74%. Then for the human written fake and machine written fake news, so when both the fake news were compared, logistic regression did the best job to separate the two. uh, then here with human written real versus human written fake news, SVM has done exceptionally well. However, we see a probability of overfitting, and we need to further iterate over it, penalizing the model, and we can actually make it more generalizable. So that's for the future experiments that we should be doing. uh, when we combine all three data sets and we try to segregate the articles. So here again, SVM gave us a quite decent results, and if you can see from the graph besides, it has done a decent job of separating out the machine fake from the human written articles. Even though there is a bit of misclassification, but still it is decent enough to start with. So as a first step, we can then further build upon it. If we can go to the next slide, to conclude about with all these experiments that we did, we conclude that machines can really mimic humans in the writing styles. Low usage of distinct words in machine-generated fake news indicates a limited word corpus. Syntactic analysis shows almost similar results in similar trends for parts of speech tags for the three categories of the articles. However, the use of common nouns is high for all three categories, and machine-generated text shows a very high count here. Lesser use of proper nouns in case both human and machine-generated articles shows the lack of facts or evidence. Simple linear algorithms can work quite well to pick out the machine or AI generated fake news articles and separate them out from the other mix of human written articles. Also, active learning techniques for data annotation can significantly reduce the amount of label data required for model training, which can lead to significant cost and time savings. With this conclusion, I would like to discuss about the future scope of the study. If we can go to the next slide. So for the future scope, we should definitely think of analyzing and comparing writing styles of various language generation models, not only with human writing style, but also amongst themselves. Uh, with these experiments, we still see a possibility to overfit. So it is recommended to explore other feature sets to make the model more generalizable. This research was more focused on the language and text classification methods. However, other features like images, videos, date and time, source of the articles, like specific publications or domains, might as well provide valuable information for the classifiers. Tracing the origin of a machine-generated fake news to the language model that it has originated from will definitely prove to be an important step towards the goal of tracing and blocking such misinformation from spreading. So, considering all these facts, and I'm sure it would have provoked a thought that we should definitely need to explore this area of research more. I would like to end my session. Thank you all.